Alright guys, so today we are going to be going over finding the slope of a line. This is right in the steps of 140 to 160, somewhere right in there in Acellus. And so there are multiple ways that we are dealing with the word slope. Now, I don't really like the word slope because it's a very mathematical word. But in reality, the word that is slope that we see in the real world is called growth. Growth is change. It's how much is a tree growing? How much is your income growing? How much is your height growing? How is your age growing? And remember that slope can not only be a positive thing, but it can also be a negative thing. It can go up or it could go down. And so let's start off by writing down. This is where you pick up your pencil. This is where you get your paper in front of you and you write slope is, let me highlight this for us. Slope is the rate that a line changes on a graph. Write it down. Slope is the rate that a line changes on a graph. And slope is represented in so many different ways. In language arts, we teach you to read words so that you can write sentences, so that you can write paragraphs, so that you can write an essay, so that you could write a novel one day, so that you can read and write in language arts. Mathematics is the same way. We are teaching you not only to read mathematics, write mathematics, but also do math. Okay? And today what we're going to do is we are going to talk about how we can do math in multiple ways. So, the first method that we are going to use is with the slope formula. I would like you on your paper to please write the slope formula. Okay? The slope formula, M is y1, or excuse me, y2, which just means the second y, minus y1, that is the first y, all divided by the second x, x2, minus x1, which is the first x. Now, I also want you to write down that slope is rise over run. It is also the up and down over the side to side. Sometimes people work better with symbology. They want to go back to ancient Egypt where they have hieroglyphs. Okay? And hieroglyphs, symbology, I know symbology isn't a word, but it's symbols. It's writing with symbols. That's what a lot of algebra is. And so when you are dealing with the slope formula, you are dealing with this formula, and you have to be able to substitute variables. Okay? Now I want you to notice that they label them for us. Notice the first x and y and the second x and y. Okay? I want you to please write down this. Take a moment and write down. The first coordinate is negative 4 comma 6, and the second coordinate is negative 1 comma 3. Now you might be beyond this, and that's good. If you are beyond this in Acellus, that is good, that is fine, this is good review. You need to know that slope happens in multiple ways because you're going to come upon a unit test in a little bit, and it is going to ask you to do this again. Just because you're beyond this step doesn't mean that you are done with it. Mathematics is cumulative. You are never allowed to forget what you have already done. And what we are going to do with this formula is we are going to evaluate our expression. We write M is, and we write our divisor, our divide bar, okay? And we're going to go through and we are going to substitute our variables. It says, what is our second y? Well, look, where's y2? Oh, here it is. y2 is 3. Minus, you should be writing this down as I write it down. I'm changing my pace so that you can write this down. And I am going to subtract the first y. Here it is, the first y. The y's rise to the top. Okay, notice it kind of rhymes. Y's rise to the top. Y is a tall letter. It's an up-down thing, okay? And it's rising on top, up on top, up and down. The up and down number goes on top. X, the second x, -1, minus the first x, -4. Now notice that we have to remember our, 6th grade math. This is called the addition and subtraction of integers. Now, dealing with positive and negative numbers is a real thing in the world, whether that's elevation or temperature or money. Positive and negative numbers exist, and we have to know how to deal with it. 3 minus 6 is the same thing as 3 plus -6. So the numerator is -3. In the denominator, we have 1 minus -4. That is the same thing as -1 plus 4, because two negatives make a positive. Now I have the math, -1 plus 4. That is the same thing as 4 take away 1. The commutative property of addition says that you can change the order as long as you don't change the value. So 4 minus 1 is 3. Now, every time you are dealing with slope, you always want to simplify your fractions. Oh my goodness, Mr. McCoy, this sounds like 6th and 7th grade math again, where we have to simplify fractions. What you learned last year matters today. So 3 divided by 3, m, my slope, is -1. The first method in finding the slope of a line uses the formula, okay? And you can always rely on the formula. This is a good situation when you have coordinates, and especially when you have coordinates that are really large numbers. All you are doing is deciding with subtraction how much did it change. The second method for finding the slope is using a table. Oftentimes a table comes in order. Notice my x's are in order, 0, 1, 2, 3, 4, 5. Notice my y's follow a pattern, 0, 2, 4, 6, 8, 10. Now, if it gives you this, you could use the slope formula, okay? What I want you to do right now is copy down this much of the table. Copy down that much of the table. Remember, in a table that goes side to side, your x goes on top. X comes first alphabetically, so we read top to bottom. So it goes x on top, the y row is on bottom. Now, mathematics is the study of patterns. And what I notice happening in this table is I notice the rate of change in my x row is increasing by 1. It increases by 1. I want you to notice that my x changed by 1. That triangle is a Greek letter that actually means delta. And delta is often used in the military, and it is a symbol for change, a change in position. Notice what we are talking about right now when we talk about delta. We are talking about how we are changing our position, which has application to the military. Now, my rate of change in the y, notice that it increases by 2. Notice that it follows a pattern. The change in y is 2. However, you cannot call your fraction 1 over 2 because y rises to the top. Slope is the y on top, the x on bottom. And we have to remember that. We write things down in oftentimes alphabetical order. That's how we make things look organized. But when we're talking about slope, the y's rise to the top. And so in this situation, I notice that my y changes by 2. Notice that my x's change by 1. You might say that the slope in this problem is 2 over 1 or 2. They are the same thing. Now I want you to notice if I did the formula, I would get the same answer. The second y minus the first y is 2. The second x minus the first x is 1. Notice if I did the formula, it still works, but we can look at this table and go a lot faster and say, oh, it changes by 2 over 1. Wow, that's a lot faster. Method number 3. Method number 3 is my favorite, not only because number 3 is my favorite number because I was born on the 3rd. I'm Alfred Joe McCoy the 3rd. I just think 3 is a fantastic number. And my favorite method for reading slope is just looking. Now looking at this screen, one of these numbers is the slope. The other number is known as the y-intercept. I want you to take a second and I want you to copy down this formula. This formula is a line's name. You and I oftentimes have a first, a middle, and a last name. That's how we are identified. That's how we keep each other separate. We call each other by our name. Okay? And oftentimes our name describes who we are and who we belong to. Now that's just, heritage kind of stuff, not like our preferences in that. But the same thing happens here in mathematics. Now that you have copied down this formula, I want you to label y equals mx plus b. Write it directly underneath it. And by the way, I hope that you put some headers above each of these. I hope that you are labeling this method number 3. Whereas the other was method number 2, and the first was method number 1. So, what do we do here? I want you to label with the word slope. And I want you to label this letter B with y-intercept. Now, when I was in 8th grade, the year was 1998, and I was sitting in my Durham Intermediate School classroom. My teacher's name was Mr. Brandel, and we were learning about the slope-intercept form. That's what this thing is. And he said, okay, guys, today we are going to learn about the slope-intercept form, where y equals mx plus b, where m is the slope and b is the y-intercept. And we looked at Mr. Brandel and we said, that doesn't make any sense. How is slope m and b is the y-intercept? I don't see how that connects. And he said, well, that's because you're saying it wrong. You got to say it like this. Slope, B, y-intercept, it just rolls off the tongue. And we said that. Slope, B, y-intercept, it just rolls off the tongue. No, it doesn't, Mr. Brandel, you're crazy. And he said, well, that's because you're saying it wrong. And we said, we thought we said it just like you, Mr. Brandel. Slope, B, y-intercept, it just rolls off the tongue. Say it again, he said. Slope, B, y-intercept just rolls off the tongue. Say it again. Slope, B, y-intercept just rolls off the tongue. He said, say it 1,000 times, and trust me, it'll roll off your tongue. And he said, we're not going to do that, Mr. Brandel. We've got better things to do. And he said, exactly. See, if you don't put in the time to learn the material, it will never come easy to you. If you put in the time and say it 1,000 times, trust me, you will remember it for the rest of your life. Do you notice I remember that saying from more than 20 years ago? I remember that story from 22 years ago because guess what? I did say it almost 1,000 times. And that has stuck with my head because, guys, that's education. If you care, it will stick with you. So, slope, B, y-intercept, it just rolls off the tongue. And once you know this fact, you know that the slope is -4/3. There's no work required because you know how to read mathematics. The slope, M, you write this down, is -4/3. The y-intercept, which is also B, is 5. There's no math involved except reading. This is my favorite method because all we have to do is read. Okay? Now, once again, if at any point I'm going too fast, I'm sorry. You can watch it again on YouTube. Next page. The next section that we're going to cover, this is method number 4. Oh, I forgot to label it, Mr. McCoy. Method number 4. Magic. Okay? Now, this one is going to be difficult if you don't have a graph paper, but that's okay. Just do a rough drawing. It's okay that you don't have graph paper. I want you to draw just a rough graph that you can see here in blue. Put a dot out here and label it -2, 4, and then put a dot somewhere over here and call it 4, 1. Just draw it, rough hand. It's okay. Draw it in. Now, method number 4 is something that uses kindergarten math. Counting. Method number 4 is counting the rate of change. How much rise is it? How much run is it? So I am going to draw a triangle. Draw a triangle. Now some of you might recognize this from the Pythagorean theorem section where you had 2 coordinates on a grid and you had to find the distance of the hypotenuse. Yeah, that's because math matters. So what we are going to do is we are going to count the slope. Remember, y on top, x on bottom. Y rises to the top. And what we're going to do is we're going to count how much it goes up or down. Now, I always start with my y. I notice that it goes down 3. Now, the number 3 is positive. How do I show that it's going down? Well, anytime it's going down, I would use the negative symbol. It goes down 3. If I'm going to the right, I am going to count 1, 2, 3, 4, 5, 6. It goes to the right 6. Going to the right is a positive number. Now, I want you to notice if I drew a different triangle. What if I drew that one? Well, let me count for you. If I go up 3, that's a positive number. Notice if I go to the left, 6, that is a negative number. Notice it does not matter which point you start at. Me personally, I read right to left, so I started at the right and I moved to the left. But it doesn't matter because math is a relationship. And when I simplify this fraction, it simplifies to negative 1/2. The slope is negative 1/2. Now here's something that's even cooler about that. I want you to notice that I'm going to go down 1 over 2 3 times. Down 1 over 2, down 1 over 2, down 1 over 2. And notice the fraction negative 3/6 is reduced by 3, and it created 3 little stairs. Mathematics is a relationship. You need to expand your thinking that it is not just about add, subtract, multiply, divide, parentheses, and exponents. Mathematics is a relationship between numbers. And if we can discover that relationship between those numbers, we can better predict the future. Oftentimes, that's what mathematics is used for, predicting the future. Okay? Now, that is the conclusion of today's lesson. If you'll give me a minute to stop this.